Okay, today we're going to be talking about section 6.2, which is titled Multiplying and Dividing Radical Expressions. And the learning target is to multiply and divide radical expressions. It's exactly how the title is. I know the target's not very creative, but it's the best thing I could think of to come up with that describes the title. So this first thing here in brown is really the only formula or theorem that I need you to know. Is that if you have any two numbers that are being multiplied, but they are also being nth rooted, so they're taking the either square root, cube root, whatever number this is on the outside, as long as they are the same and they are real numbers, then what you can do is you can multiply them together so that the numbers on the inside are being combined under one radical symbol. So let's take a look at an example down here. We have the cubed root of 6 being multiplied by the square root of 2. Since this is a cubed root and this is a square root, these cannot be combined and they cannot be simplified. So this is your answer, or you can say does not simplify. Looking at an example with ones that do have the same numbers on the outside, you can rewrite them as the cubed root of -4 times 2, which is the cubed root of -8. So all you do is you combine the numbers on the inside and keep your cubed root here on the outside. Okay, and simplifying any of these numbers on the outside is still the exact same thing like we did in the last section. 54, when finding perfect cubes instead of perfect squares of the factors, you find the cubed root of 27, since 27 is a perfect cube, and you take 3 of the x's from your original 5, because you can't take the cubed root of 3. Then everything that's left over is the cubed root of 2x squared. 27 times 2 gives us 54, and x cubed times x squared gives us x to the 5th. This is exactly like the last problem, except we're moving backwards, where we're splitting this up into 2 different factors and simplifying from there. So the cubed root of 27 is 3, and the cubed root of x cubed is just x without any exponents. Then everything right here underneath this radical stays exactly the way you see it, and this is the most simplified answer to the cubed root of 54x to the 5th. Looking back over at the next one, the perfect cube of 128 gives us 64, and since we have 7 x's, the highest cube root taken from that is 6 x's. Everything that is left over is the cube root of 2x. 64 times 2 is 128, and x to the 6th times x gives us x to the 7th. So you want to find the factors of 128, and the highest one being a perfect cube. We can take the cube root of 64, giving us a whole number, and that is 4. And the cubed root of x to the 6th is x squared. Since we have x raised to the 6th divided by 3, 6 divided by 3 is 2. And everything here underneath the radical is the same. So this is my answer. Okay, and make sure you don't write it like I just did, where this exponent kind of bumps up next to the index for the radical, and it makes it look like it's x raised to the 23rd power. Just make sure you're kind of spreading them out so I can tell the difference between each of them. A few more examples. We have the square root of 72 x to the 3rd power times y to the 2nd power. Then this is also being multiplied by the square root of 10x y cubed. Now, using that first theorem we had, since these are both index of 2 on the outside, we can multiply these together. So we have the square root of 720, multiplying the two numbers. X to the 3rd times x to the 1. We add our exponents. 3 plus 1 is x to the 4. Y to the 2 times y to the 3. Add our exponents. 2 plus 3 is 5. Then back from here again, we can split them up, where the highest perfect square of 720 is the square root of 144. We keep 4 of our x's and 4 of our y's. since those are the highest perfect squares inside those factors. And everything that is being left over is 5y, not 10. 144 times y is 720. And then we have 4 x's that are all here. 4 plus 1y is 5y. Okay, the square root of 144 is 12. The square root of x to the 4th is 4 divided by 2, which is 2. Y to the 4th divided by 2 is the same thing, y squared. And you keep your radical of 5y exactly how you see it. Alright, and since I've ran out of room, I'm going to move this problem down here, and I will change colors. Alright, multiplying these two numbers together, 45 times 35 gives us 1,575. 5x's plus 1x is 6x's, and 3y's plus 4y's is 7y's. Now the largest perfect square that can be factored out of this is the number 225. The largest perfect square that can be factored out of x to the 6th is x to the 6th. And out of y to the 7th, the largest perfect square is y to the 6th. Everything that is being left over, so the other factor of 225 that is being divided by 1575 is 7. We have all of our x's over here, and we took out 6y's, which means we are left with 1. The square root of 225 is 15. X raised to the 6th divided by 2 is x cubed, and same thing with this y. Raised to the 6th divided by 2 is y cubed, and we keep our radical just like that. So the main goal in these two problems is to combine them together to form one radical, then find the largest perfect square factors, and leave everything else that you can't take the square root of underneath the radical. So this is the most simplified answer to this problem up here. Now you can stop early, but you will not receive all the full points when it comes to the day of the quiz. So make sure you are factoring completely everything out that you can take the square root of. If this was a cube on the outside, we would be finding largest factors that are the cubic roots. Okay, and the last two that I want to go over is the exact same idea, but instead we are looking at division. So since the first theorem I showed you was two things being multiplied with the same index, you can combine them. The same kind of idea can be applied to division. Since we have one radical being divided by another and they both have the same index of 2, you can combine everything underneath the radical. So 18x to the 5th over 2x cubed can all be underneath one radical. Then from here you just simply reduce everything underneath. 18 divided by 2 is 9, and x to the 5th minus, or divided x to the 3rd means we subtract our exponents. 5 minus 3 is 2. And the square root of 9x squared is 3x. So combining everything underneath one radical, as long as the indexes are the same. Looking over at this one, our indexes are both 3, so we can combine them into one cubic root of 162y to the 5th divided by 3y squared. 162 divided by 3 gives us 54. And y to the 5th divided by y squared means we subtract our exponents, so this gives us y cubed. The cubed root of 54 can be factored into the largest cubed root, which is 27. We're going to keep all three of our y's since it's a perfect cube, and the other factors is the cubed root of 2. The cubed root of 27 is 3, and the cubed root of y cubed is just y. And then we keep our cubed root of 2 right over here. Okay, so once again, the main goal is to factor everything out completely and simplify. If you stop right here at the 54, we still have a few more steps left. We find the factors of 54 and the largest perfect square, which is, or perfect cube, sorry, a perfect cube, which is 27. From there, you simplify everything underneath, and whatever's left over in the other radical, you just keep it right there. Okay? Thank you.